Hello, my name is SPoveda. I am a student from Escuela Politécnica Nacional in Quito, Ecuador. This video is to explain the functioning of the Pmedian algorithm made in MATLAB. I also have made a function with this algorithm to automate this with any problem. First I'm going to explain this algorithm just with a specific problem, and then I have made the function to use this algorithm with any problem associated with this phenomenon. First, what is the reason why an algorithm is made? The reason is when you have a problem. Also, the problem is this. To implement the Pmedian algorithm for this exercise. This is the matrix of distance of machines, and this is the number of groups that we want to have. Okay. And also we have here the solution to make sure that the algorithm is working well. And now we are starting with the algorithm. The algorithm is this. Okay. First, to resolve a problem, first we plantate the information that we have, and the information that we have is the distance matrix and the number of groups that we want to have. We want to have 2 groups, and we have here the distance matrix. Is this, but pass in this language. Okay. In this format. Then we establish this D2 because these matrix D are going to change with the algorithm, are going to change, and then at the end we want to compare these 2 matrix, the original and the change matrix. Okay. First, we start making two vectors, okay? The n and the m vectors, okay? The n and the m values, I'm sorry for that. The values of n and m is the size of the matrix. Always the matrix are square, so the number of files is the same of the number of columns, okay? So these 2 values is equal to the number of columns and the number of files. Then we make a matrix of 100, okay? Of make 1000. I'm sorry. We make a matrix of 1000 with the same size of the matrix D. Okay. I'm going to explain what is the reason that we make this matrix at the end of the program. Okay. First we start with a counter. Okay. With a counter for the vocal 4. Okay. For this algorithm we are going to use a vocal 4, and then I'm going to establish these 3 vectors. Okay. These 3 vectors are so important in this program. Okay. First, the total vector is a vector of zeros that are going to change these values, but now is a vector of zeros with the size of the number of columns. Okay. And the f vector and the minor vector, okay, are two vectors with the number of we decide the number of groups. Okay, the number of files is the number of groups of groups. In this case are two files and just one column. Okay, and here we have just one file and 6 columns because my matrix is 6 per 6. Okay, yeah. This total matrix is the summatory of all the columns. Okay, of each column all the files. Okay, and thus first the summatory is going to be 0 plus 6 plus 1 plus 1 plus 7 plus 6. Okay, so the total matrix first is gonna be 21. Okay, and the same with the other columns. Okay, for that reason is a vector of just one file and 6 columns. Okay, the number of columns that have the original matrix. Yeah, then the f vector. Okay, I'm going to explain the minor vector. Okay, the minor vector it's going to identify the minimum value of the total vector. Okay, the minimum value. So here we have the total vector. Okay, here we have the total vector with the summatories of all the columns, the summatory of the first column, the summatory of the second column, the summatory of the third column, and this with all the matrix. Okay, and here's the minor vector. Okay, just identify the first value, the minimum value. It's gonna be 3, but we always choose the first one. Okay, the first one, that is the minimum. So in this case we chose this, and then the f vector is the vector that identifies the position of the minor value. Okay, so the position of the minimum value here is the first. Okay, the first position. So for that reason f is going to be 1. Yeah, then this part of the algorithm is to do what I said minutes ago. Okay, the total is a summatory of all the files of each column, and here is to identify the minor and the f. Okay, then I'm going to explain this part. Okay, yeah. This part is to compare. Okay, is to make zeros in the file that is the minimum value. Okay, so the minimum value was 1. Okay, so all of this column, all of this file is gonna be 0 because here is the minimum value here, and I'm sorry, and because this column is the minimum. Okay, that we identified with this with f, and the minimum value is 0. So in this case all of this is going to be 0. Okay, all of this is going to be 0. Yep. And then and then we establish, okay, we compare the minimum value, in this case is the first, okay, is the first of each column. So the first we compare with this 6 and 6 is going to be 6. 6 and 0 is going to be 0 because it's the minimum value of the comparison, and 6 and 0 because here is the number 1. For that reason I chose 6. Yeah, and same to all the file, okay. 5 and 6 5, 5 and 6 5, 3 and 6 3, 4 and 6 4, and like this to all the matrix, okay. In this case 5 and 1 1, 0 and 1 0, 2 and 1 1, 8 and 1 1, 5 and 1 1. All of this file is gonna be ones and just 1 0. I'm gonna show you what I say, okay. What I say. Okay, here is, okay, and then same to the other files, 1 and 5 1, 1 and 2 1, 1 and 6 1, and 1 and 7 1. Okay, here in this file is gonna be 7. It's gonna be the same number, 7 and 3 3. In this is gonna be 7. In this is gonna be 6 0 and 3. And this value change by 6. Yeah, and the final in this case is gonna be this, okay. Yeah, these two files of 1, and then just this value change for 7, and just this value change for 6, okay. Yeah, and then we change this first one we change in, because it's the number 1 is the number 1 column, and we change the matrix of W that we established with 1000 by these values. I'm going to explain it at the end what is the reason for I changed these values, okay. Yeah, then with the matrix of D that I have, because at the start of the video I said that the matrix of D are going to change. With this matrix I restart the process again, so I'm going to summatory all the columns, okay, and the summatory total is this. Yeah, so now the minimum value is gonna be another one than the first, okay. The minimum value is 8, okay. So this 8 is the distance, yes. 21 is the first distance that I chose, and 8 is gonna be the second distance, okay. So I put 8 in the minor vector, and F identify the position of this minimum value. So in this case the position is the 5th, okay. 1 2 3 4 5th, okay. For this reason the F vector is 1 5, because the first minimum value was in the position 1 and the second minimum value was in the position 5th, okay. And now I'm going to do the same with the matrix D, okay. In this case this file is gonna be 0, okay. This file is gonna be 0 0 0 0 0, okay. And also I compare the values of this column, okay, the values of this column. So 5th and 6th is gonna be 5th, okay. Yeah, wait a minute. Yeah, I'm going to compare, okay, the of this column, I'm sorry, of the 5th. So 3 and 6 I'm sorry, 3 and 6 are gonna be 3, 3 and 0, 0, 3 and 5, 3, 3 and 3. Okay, so the matrix, it's gonna be like this. Okay, and again with the other values. In this case is 1 1 1, 1 1 1, 0 0 0, what I want, and in this case is 3 3 3 3 and 0. Okay, and the final matrix D that I have, the final matrix D, gonna be this. Okay, yeah, and finally I change these values in the matrix W that I have. Okay, yeah, I have this matrix W, and finally I have this command. To find the minimum value of the matrix W. Okay, so the minimum value here is 0, okay, and the minimum value here is 0, okay, is in the column 1 and in the column 5th. Okay, and then this command is gonna be compare this one with the minimum values. In this case, the minimum values of this for that reason I change the column of the matrix W. Okay, so the minimum value of this column without 0 is 1 and 1. Okay, so the number 1 relationship with number 3 and with the number 4. Okay, and in this case the number 5th relationship with number 2 and with the number 3, and I just put a key put here to show me with what files relationship each minimum value, each 0 value of the columns that I established in the first command. Okay, so this value 0 relationship with number 1 and number 1. So number 1 relationship with 3 and with 4, and number 5 relationship have a relation with number 2 and number 6. Okay, so the solution is this. Okay, 1 1 3 1, the number 3. Okay, the number 3 column, the number 3 file with the first column, and number 4 with the first column, and then the number 2 file with the 5th column, the number 5th with number 5th, and the number 6 with number 5th. Okay, yeah, and this is the distance. Okay, first I established the distance 21, and then I established the distance 8, which is the minimum, obviously the distance 8. So first I'm going to start with the number 5th. Okay, to have the distance 8, and then this print I put here. Yeah, I put here this print. This print I put here. Okay, to let me see what is the minimum value. Okay, the minimum value of the vector minor. Yeah, that I explained. Okay, the value of the vector minor. Here is the vector minor. So the values of this vector minor, the program is gonna show me 21 and 8. Okay, in order, first the 21, because QTD is the variable that is a variable that have a values from 1 to the number of groups, from 1 to 2. In this case I can change it. Okay, it's in this problem the number of groups is 2. Okay, yeah, and I have the solution of this algorithm. Yeah, But in this case, to explain you, I eliminate these ones to show me what the program does, okay? What the program does. But now the program is gonna show me just the answer, okay? It's what we want. Okay? So the program is gonna show me just the answer. Yeah, here. Yeah. The program just show me the answer. The minimum distance from P1 the P1 is the number 2, is the number 1, I'm sorry, is the number 1, and the P2 is number 5. So the distance from number 1 is 21 and the distance from number 5 is 8, okay? And here is the solution, the relation of the machines: 1 with 1, 3 with 1, and 4 with 1, and the other group, we want 2 groups, and the other group is 2, 5, 5 with 5, and 6 with 5. Yeah? And for automate this algorithm, not just for this problem, for every problem similar with this, I have a function. I have made a function, okay? So in this function, we are going to establish just in this function we just put the function. We just put the function, and the first value that we have to put this function, we have two arguments, okay? We have to put 2 arguments in this function. The first argument is the matrix, so I'm going to copy the matrix that I have here, okay? I'm going to copy the matrix that I have here, I'm going to copy the matrix that I have here, okay? And I want more number of groups, for example 3 groups, okay? So I have here the minimum value is 5 in this case, and I have here 1 with 1, 3 with 1, and 4 with 1 is the number 1 group, okay? The second group is 2 with 2, just this group, and the third group is 5 with 5 and 6 with 5, okay? But here, when we have more groups, we have less distance that with the other problem with 2 groups, okay? But in this case, maybe we have more interchange moves, okay? And this algorithm, it's not just for this. With this matrix, you can put any kind of matrix that we have, distance matrix, okay? I'm going to put another that I have here, okay? So okay, so I have another matrix, okay? It's gonna be the matrix A, okay? I'm going to copy this, okay? But I have to erase this, yeah. So this is my matrix, and I'm going to put this in my program, okay? This is the matrix, and I want 7 groups because this matrix is so big, so huge. So I want more number of groups, and I just enter, and I have the solutions here, okay? The minimum distance is 44, yeah, okay? And then I have the groups: 1 with 1, 3 with 1, maybe we have here another group, 13 with 1 and 14 with 1, okay? And like that, we just take the same numbers and just we make the groups. But here is the solutions. Okay, here we have 7 groups. Yeah, so that's it. Thank you to see the video, and I hope you are going to use this. Okay.